evening, everyone. So we'll start off with I'm Kamiya, this is Prasad. We will be talking about how to enhance customer experience at Walmart using AI. What are the AI technologies that we are using? So let me just talk a little bit briefly about some fun facts about Walmart. How large is the scale that we are operating at? I think a lot of you might already be familiar with it, but I'll still cover it. So we are operating in 19 countries with around 10,500 stores and clubs, basically Walmart stores and Sam's Club. And we are a people-led and tech-empowered omni-channel retailer. Basically, we use a lot of tech in making the lives of people easier who are making all of this happen behind the scenes. And we have around 2.1 million associates worldwide, which are actually involved in making all of this happen from tech to on ground. And we are talking about a scale of revenue of over $600 billion. And another fun fact, approximately at least 90% of Americans live within 10 miles of a specific Walmart or a Sam's Club store, which is pretty, basically it's talking about how accessible these stores are to the general public and the volume of the interactions that are going to happen. So let's move on to what our core mission is. So the core mission for Walmart is to help people in saving money and living better. So we want to make people's lives easier whenever they are coming to shop at Walmart. And this core mission is pretty much at the heart of every idea. So you'll see it as a recurring theme in multiple of the use cases that we'll touch upon. So I'll actually start off with talking about customer experience in personalization and search. Okay. So before I go into these use cases, let me talk about how I'm going to structure this part of the talk. So basically, we'll first start off with zero query, where the user intent is not fully clear. And then we will go to one query, which is basically when the user is searching for a particular item. And they will actually give us the exact query, hey, this is what I'm looking for. So we will first start off with zero query. And I'll actually start off with something called a substitution experience. So basically, I'll be talking about how do we personalize the online grocery substitution experience. So why am I starting off with this use case, right? So the reason for starting off with this use case is because it is a very truly omni-channel experience. Why? First, because the user places an online order. So like you see the cart, the green colored cart. So the user has placed an online order. Then in the store, there's an associate which is actually preparing that order. And these stores are also open to live traffic. That means that the fulfillment is happening with the customers also shopping parallelly. So what happens when a customer has already placed the order and an item is not available or it is out of stock? Now, this problem can happen at scale. Even though it happens, it is a rare sight, but it is a very important problem if it's happening at a scale. Why is it again important? Because we don't want to leave holes in customers' basket. A very simple example, let's say I had planned on making sandwiches tonight. And I placed an order over Walmart saying, hey, I want bread and I want XYZ things. Now, if the specific bread that I ordered is actually not there in the store, and if it is not substituted with something else, then it will basically leave my plans, then I'll not be able to make a sandwich. So this actually happens a lot in our real lives as well. We just don't realize it. We don't place the name of substitution to it. For instance, let's say I'm going into a store and I wanted, hey, this particular kind of brand of brown bread, but it's not there. Will I come back without the bread? No. I will actually pick up something close by. So what we are trying to do is basically automate this process for the user when the user is not there in the store to actually make the best call. So here, I'll actually talk about some key pieces that actually go in building this solution. So we use deep learning. Basically, we actually use a graph convolutional network to actually build this whole system, where we take into context all the order context. Apart from that, specifically which item has gone out of stock. What are the available options? Again, this can also vary from store to store, and it is also very highly susceptible to the demand and the actual traffic in the store as well. Then we also take into account personalized signals. So personalized signals meaning, let's say milk is out of stock. So for two users, let's say Joe versus Jane, they might have specific preferences for milk when it comes to shopping. So we also want to be aware of who the user is for which we are making this, this substitution. And I also want to talk about the cross-channel behavior. Let's say I placed a few orders offline, like while I was shopping, I went into the store and I picked up these 5 different kinds of items in the past. Can I learn from that when my item goes out of stock in future, I would want to leverage this information in the online in the online order as well. So that's why I was talking about the omni-channel part of it. Then there are constraints as well, which are pretty interesting. So this is a very highly precise, the need for precision in this problem is very high. Why? I'll tell you that in a minute. Because you're taking a decision on behalf of the user in a post-transaction setting, and there are pricing that comes into the play. Let's say if I ordered like a $5 item, please don't go ahead and substitute it with a $15 item. Or don't also go too much below as well, because I want to be aware of the quality that you were actually looking for. Then there is quantity as well. Let's say I was trying to bake a cake and I actually wanted, let's say, 1 kg of flour. So when I'm making the substitution, I should also either substitute it with a 1 kg of another flour or 2 half kg packets. So there are these inherent constraints that also come in. So it is not just a precision and recall play, but the need for precision is also much higher. And I also want to talk about how data drift plays a role here, which is basically, okay, so at the time when the pandemic had hit, a very simple example I'll actually give. So people were looking to stock their refrigerators. Now, let's say I ordered strawberries. At that time, I'd probably have been okay with receiving frozen strawberries as a substitution. And then that would flow back into the data. Hey, this is a good substitute. But after the pandemic was over, when people came back to their normal shopping patterns, the data again changed. So the need for us to actually act on this data drift is very important, and it has to be acted on with speed. One would think that after the pandemic is over, the data would be, back to its normal behavior, but not really. Why? Because let's say there's a store in Hawaii versus there's a store in New York versus there's a store in California. They will have a very different trend of what is a good substitute for, let's say, one fruit versus the another fruit. So there is a potential for the data which is getting collected in one store to actually impact another store. So how do we ensure that we are actually leveraging this in the right way possible? Yes, there is a lot of leveraging that should happen. For instance, you should understand that for a brown bread, you should probably substitute it with another brown bread only. Do not substitute it with a white bread. People don't like it. So how do you do that leveraging while also doing the localization? That is important at that moment in time. So this is one particular use case. Just wanted to deep dive a little bit into this. Moving to expanding this to other zero query use cases that happen. So how do we personalize the customer interaction that is happening online? So the first carousel that you see, which is basically a similar items carousel, that basically plays a part in the discovery journey for the user. So if a user is looking at a particular item, how do we show them other similar kinds of item and make their journey a little bit easier? So here, this is a little bit different problem than before, because here this is a pre-transaction. The user is still there, and the user is going to add to the cart. So we can basically have more recall, we can play around more, show more options. And the constraints are also different, which basically changes the whole problem setting when I talk about it from a machine learning perspective. So here we use wide and deep neural networks to actually build these kind of models. Then another use case is reorder your essentials, which is part of our inspirational journey. So let's say if you keep ordering over Walmart, if you're a very regular customer, I can predict, hey, after 6 weeks, you probably get laundry detergent again. Or you actually shop at Walmart every week for these are your essentials. So how do I make it for like a one-stop for you where you don't have to keep doing that exercise again and again, and you can just come to one place, something we call it as predictive basket, where you will be actually shown with all of the items that you're likely to purchase at this time, and then you can just go ahead and add all the items to the cart. And here we again use deep learned models like LSTM. So I'm just trying to explain different kinds of deep learned models that are specific to different use cases and how they play into part in various use cases. So Okay, now I will move on to the one query part of it, where I'll be talking about how are we elevating the search experience. So let's say a user is looking for a red formal shirt for men. So here, there are three pillars that actually take place. The first pillar is query understanding, the intent of what the user is typing. So let's say here the color is red and the user is looking for formal shirt and looking in men's shirts. So once we've actually understood the intent of the query, then we go ahead, and the second pillar is actually retrieving the right set of relevant items for this particular query. And then the last set is actually how do we rank these retrieved items in the most optimal way for the user, and basically ensure that it is as related to the query that the user was looking for, and if they have also potentially put in filters for pricing and other things. So again, we use underneath, we use a lot of multiple deep learned models go in making this experience happen. And at the base of both of these experience, zero query, one query, is a lot of metadata. As you will all know that data science relies heavily on the presence of clean data. So we also put in a lot of machine learning in enriching our product catalog. Here we use multiple, again, here also there are like hundreds of ML models that go underneath. A lot of them are bird-based custom models, which basically go in and actually extracting attributes. So here, imagine that there are a lot of suppliers, a lot of people who are creating this metadata for these items. Now, again, this is also an extreme precision problem, over 95%. Why, for instance, somebody has given me a large text. There can be only one brand associated with one particular item. And so many downstream systems are going to use it. So I have to ensure that the information that I'm extracting is highly precise. And again, we have over 20 million items that get enriched monthly by this. And we have like thousands of CPUs and GPUs that go in like training this and ensuring that, again, we are also up to date in terms of what are the new items, how the metadata is changing. And yeah, so basically I've talked about how we use deep learning in various experiences in search and personalization. I'll hand it off to Prasad now to talk about pricing and delivery related customer experience.
Thank you, Kamiya. Okay, so you heard from Kamiya what Walmart is doing to help people save money so that they can live better, right? Now, I'll talk about two things which are very important from what govern a customer buying choice in the customer experience journey, right? So pricing and delivery. Now, one of the things Walmart's core philosophy has been of everyday low price. Now, what do we mean by everyday low price? Everyday low price is not basically just a pricing strategy. It is a commitment to provide a fair price to our customers every single day. Now, think about it. We have hundreds of millions of items on our catalog. Prices change, as you know, every day. How do I build a setup which can say and tell me that whether I am delivering on this promise? That's a significantly challenging problem Walmart has to tackle. Towards this, the foundational system that makes this possible is what we call as an item matching system. Now, what we do at the item matching system, the core of this is we link items which are similar together. Now, how do we do that, right? So we take billions of items from the retail universe, we index them in a vector store. We use transformer-based architectures to transform unstructured data, both text and images, into embeddings. Then we use, for any given item on Walmart, then we look for similar kind of items and we generate a set of potential candidates. Right? For that, we use a set of nearest neighbor algorithms. We use similarity algorithms, which can generate potential candidates which could be compared for this item. But think about it. Now, items have different nuances. We have hundreds of thousands of product types. Think a phone. For a phone, the RAM is important. That governs the price of that item. For a bedsheet, a thread count is important. For a book, the year of publication is important. So, and it goes on, right? So how do you build a model which can work across hundreds of millions of items, is able to do precise matching? For this, we use fine-tuned LLMs. We have built significant innovation in terms of featureization techniques, as well as we plug in our own custom loss functions, which are helping us generate matches which are of extremely high precision. Imagine we have this setup, we look at what kind of prices we are providing, and then based on that we are updating the price. If I have one wrong price, I could actually have a significant loss happening or a significant drop off because of customer experience. So this is something which is powering and help. With this kind of setup, we are able to ensure that we are able to deliver the promise of EDL. Also, this is something which the linking is not static. Every day attributes change, new items come to the fore. So we need to be able to maintain this linking on a daily basis. So we do this for hundreds of millions of items every day. And like I said earlier, prices change every day. So we need to ensure that we are benchmarking multiple times in a day so that we are compliant with our core philosophy of EDL. So that's on the pricing. Now let's look at delivery. On delivery, this is another important factor for customers in their buying journey. We all want, when we order something, the delivery to happen fast. We also want the estimated delivery time to be reliable. Now, typically we measure delivery using what is known as the on-time delivery benchmark. Right? What we saw with data was sellers on our marketplace were trying to provide conservative estimates on the delivery benchmark on the delivery times because they wanted to make sure that they are compliant with the on-time delivery SLAs. So we built smart tags. So what smart tags does is, it looks at a whole lot of data which are used from the item, the shipping data, and the seller information. And based on that, it recommends what could be a good delivery date, which we can fulfill without compromising on the on-time delivery benchmark. So using classical ML techniques, we have built this. This is something which is live and is able to provide significantly better delivery estimates. This has been a win-win situation for both the customers and the sellers on the marketplace. Customers get faster delivery times. From the seller point, they get significantly more conversion as well as significantly more revenue because of this. So this is on the delivery side. Right? Now, Kamiya will talk about what are we doing in terms of next-gen processes in the retail world.
Thank you. Okay. So I'll first start off with the next-gen experience for conversational AI which is an in-house conversational AI platform called Converse. So I will actually talk about how this conversational AI platform is used within Walmart. So the first use case that you see on my right is the shopping assistant. Basically, what shopping assistant does is it is integrated with Google Assistant and Siri, and you can also text. So whichever phone you are using, you can actually say, hey, add paper towels to my cart. Internally, what will happen is we will also look up what is your preferred type of paper towel if you've actually shopped with us earlier, so that you don't have to keep telling us the same information again and again. As much as we can extract from what we already know, we will go ahead and add your particular preferred kind of paper towel to your cart. So this is how it plays part in the user's journey, customer journey. The second part is customer care automation. So here again, there are based on the user context. So here in all of these three use cases, you will see we will be using natural language processing and personalization, and there are like bird-based custom models sitting underneath. So here again, based on the personalization information that I already have, did you actually recently place an order with Walmart? So then we'll actually show you tracking information. Most likely you're probably looking for tracking information or where your order is. So what is your intent based on your particular profile? And of course, you can also come back and tell me, hey, which aisle is this item in, or where do I go? So you can also ask questions like, where in the store is a particular item? So Walmart stores are pretty huge. So if you're actually looking for only a few specific items, you'll exactly know, hey, this is the aisle that I need to go in, and the whole experience becomes much more optimal. Then the third part is associate facing app, which is the hands-free for associate. So basically, if there are drivers delivering particular orders, or there are associates in the store making, making those orders for the customers, so they can ask questions like, what is my schedule for today, and what is the next order I need to deliver. So basically, there are these multiple use cases that are actually powered underneath by one common platform. And we are also sort of experimenting with Gen AI in this space and search. And so going to another kind of next-gen experience, which is basically how do we leverage AI in stores as well. So here the first part is figuring out what kind of assortment should Walmart carry in the first place, right? So how do we build the optimum scalable assortment? How do we optimize revenue profits? And how do we place constraints on the space and categories? Because there's only a finite space in which these items can be placed. So once we have figured out that these are the items that Walmart should carry, second part of it is how should these be placed to make sure that similar kinds of items are actually placed close by. Then there is of course the moving components of demand forecast and assortment. So if the demand keeps changing and the assortment also has to change accordingly. Then the third part of it is how do you also automatically change the modular arrangement for these items. And then, of course, how do you place groups of items together? So basically, which category should be next to which other category? So again, we use a lot of AI underneath in all of these models to actually identify how do we optimize how items are actually placed in the store. Then I will cover another next-gen experience use case, which is pretty interesting. So we have something called as robotic scrubbers, which are powered by Sam's Club. So this is pretty interesting. These are like these automated floor scrubbers, which actually keep moving in the store, and they're also cleaning the floor. At the same time, they also have cameras attached on top of them. So what do these cameras do is they keep taking pictures on the shelf of what the item is. Is there like correct pricing there? And we deploy deep learning technologies underneath to actually process all of these images that are getting captured. And then we use it as a feedback mechanism to also verify is the pricing that is getting displayed on the shelves, is that correct? Are there product stock levels, or do we need to restock those particular items? Then product localization, let's say if something is placed very high up on the aisle, is it actually accessible to the user? So if it is not, then it can be brought forward. And these inventories can actually act as a feedback back to multiple inventory systems underneath that we use. So these were just a glimpse of some of the next-gen experiences at Walmart. I'll actually hand it off back to Prasad to talk about how do we nail the fundamentals.
So you all saw a whole lot of use cases Walmart is able to leverage AI, but how is this possible? And this is, Walmart has built a significantly strong AI ecosystem, which helps us infuse AI in everything we do. Now, when you're building an ecosystem, it is a coming together of multiple things. Firstly, data, then the people, community of AI practitioners, platforms, tooling, infra, but the most important probably the culture and mindset around that. So I'll touch upon two of these. I will not get into the rest of them. So Element is our ML platform today. It's used by everybody within Walmart. It has all the bells and whistles you would expect from a data science platform. It provides every data scientist what they need, ability to interface with any kind of data store within Walmart, ingest that data, do EDA, build models, experiment with models, have sandboxes, all of those things. The things which make it really good for an enterprise is the ability to take those same models into production with one touch. You don't have to do much in terms of production. Secondly, your ability to scale on-demand infra. We know all our new algorithms are GPU hungry. So how do I get on-demand infra for my POCs or for my production deployments? So that's something which comes in. You're then having an ability to collaborate with project artifacts across teams. And the most important thing which it promotes is a marketplace mindset. So Walmart is a very large company. We have significant innovation happening everywhere, right? And by having this platform, it allows us the ability to leverage each other's work and accelerate the pace of innovation. So imagine somebody has built, some team in Walmart has built ability to extract text from images, and they are using it for their core charter. But today, if I need it for my item matching, I could easily go to Elements, use their endpoint, and get the same functionality in minutes. Now, this helps me to accelerate very, very fast. And my ability to pilot new things becomes extremely small. So that's something we have done from a platform perspective. And I talked about culture. We have been doing a lot of things in terms of nurturing the culture and the mindset. One of the important things is to build the rigor and the mindset for innovation. We have deep academic connections, but we are deepening it even further. Today we have an agreement with IISc. We sponsor students for a full-time MTech at IISc. This is as the same level as a normal MTech you would get. This is MTech in AI, which you would have got from the GATE exam. We also have a lot of research collaboration. We work with professors from IITM, where we collaborate and further areas in terms of new work. We Converge and AI at Walmart are our two annual conferences. You should visit them to get a view of all the work we do at Walmart in much more detail. A great occasion for knowledge dissemination. Similarly, we are on the program and organizing committees of various prestigious ML conferences. Also this year, we are delighted to say that we are been awarded the 2023 Informs Prize. This is for excellence in operations research and analytics. For our work in supply chain, merchandising and forecasting, we have been given this award. So as you saw through the talk, we have been doing a lot of work in AI. We have a significantly vibrant AI community at Walmart, and we are confident that we will continue doing a whole lot of things to improve the customer journey as we go along. With that, we'll wrap up. Happy to hear your comments or take questions.